This is the day that I've been looking forward for 2 years. As Steve Jobs said, every once in a while, a revolutionary product comes along that changes everything. One is fortunate if gets to work on just one of these in one's career. But our team has been very fortunate to be able to introduce a few of these into the world. In 1983, I co-pioneered high-precision GPS at Trimble by introducing Trimble 4000S. It was a 4-channel geodetic receiver. I single-handedly wrote its entire software, 16 hours a day, 7 days a week for several years. It was the first commercial geodetic GPS receiver, and it really changed the geodetic survey industry. Later, after I founded Ashjaee, in 1989, we introduced Ashjaee L12. This was the first all-in-one, all-in-view 12-channel geodetic GPS receiver. After that, we introduced Ashjaee M12 and the legendary Ashjaee Z12. These were the first truly portable geodetic GPS receivers. We're also the first to integrate GPS and GLONASS satellites. In 1998, I founded Javad Positioning Systems, JPS, and introduced Odyssey, Regency, and Legacy products, followed by Hyper. It was a 76-channel geodetic receiver. Other companies later copied Hyper. Today, many of GNSS receivers look like it. In 2007, I founded Javad GNSS and introduced Triumph products. These were 216-channel receivers integrated with several communication channels. We also introduced their Alpha, Delta, and Sigma versions. We were again the first to offer Galileo tracking in mass production. Well, today, in June 29, 2010, we are introducing 3 new revolutionary products of this category. First one is a revolutionary high-precision GPS GLONASS Galileo geodetic antenna. It has astonishing high-precision performance. It is a stacked patched antenna capable of tracking all GNSS signals. It has ample ground plane to reduce multipath. It also has very good face center stability. It is a great, compact, high-precision geodetic antenna. Second one is a high-precision GPS GLONASS Galileo GNSS receiver. It has 216 channels and is integrated with all-frequency UHF, also has worldwide GSM with dual SIM card, also Ethernet, Wi-Fi, and Bluetooth. It also has more than 10 hours of removable, rechargeable battery pack. The integrated UHF, GSM, Wi-Fi, and Bluetooth antennas are nicely secured inside the receiver, away from any interference or obstruction. And the third is a breakthrough widescreen, high-resolution handheld controller. It has both touchscreen and quick action buttons. The screen has 800 by 480 pixels. To put this in perspective, this is 4 times more pixels than iPhone. The controller is also loaded with breakthrough application software. Let's look at its home page. The status icons on the top show the status of some essential items. These top icons appear in all screens. The software provides tools to perform all sorts of jobs like designing shapes, surveying points, surveying boundaries, monitoring structures, stakeouts, and GIS tasks. We have designed these in a way you've never seen before. The software is also loaded with many maps and over 3,000 worldwide coordinate transformations. In a menu, you can select among point survey, parcel survey, trajectory survey, stop-and-go survey, auto stop-and-go survey, stakeout, stake survey, structure monitoring, fixed base station, and follow trajectory actions. These selections prepares its action screen to do the job accurate, fast, and easy. The dynamic action screen is so cool and makes it a joy to perform all sorts of survey and GIS tasks easily in the field. Everything you need to know and see is nicely designed in this smart screen. So 3 things: a high precision, all frequency GNSS antenna, a new GNSS receiver, and a breakthrough handheld controller loaded with a revolutionary application software. I repeat, a high precision GNSS antenna, a state-of-the-art GNSS receiver, and a breakthrough controller. Am I not clear yet? These are not 3 separate devices. Today, we are reinventing the GIS and survey industry. Today, we are introducing Triumph VS. Let me show it to you. First is the functions and the design. We have designed something wonderful. It fits in your hand so nicely. It is lighter than a professional camera. Let's focus in some of its details. Here you see the overall view of the Triumph VS. The high precision antenna is on the top. There are also 5 quick access program buttons, which I will brag a lot about them later. High precision GNSS receiver is inside a solid magnesium alloy case. In the back of the receiver, there are high capacity, rechargeable, removable battery packs, GSM, GPRS antenna, Bluetooth, Wi-Fi antenna, and UHF antenna. They are all safely secured away from the interferences and blockages inside the receiver on both sides of the battery packs. Behind the removable battery pack are removable GSM SIM cards and removable micro SD memory cards. On top of the battery pack, there is a 3-megapixel camera to record images and videos along with the GNSS data. Hand grips are on both sides of the pack. Under one hand grip, there are 4 connectors protected. They are external power, 2 USBs, and Ethernet connectors. Under the other hand grip, 4 connectors are protected for 4 of the following 5 options: external GNSS antenna, external UHF antenna, 1 pulse per second timing signal, event marker, and external frequency input output. On both sides, there are also eyelets for shoulder strap and mounting options that we will discuss later. On the bottom of the receiver, there are 3 connectors for mounting Triumph VS on a variety of tripods, monopods, poles, and machines. Also in the bottom, there is a high-resolution camera for continuous alignment to the mark and recording the alignment offset along with the GNSS data. Also, in the bottom, there are 2 high-quality speakers for audio signals and voice. And in front, there is the display and keys. It is a 800 by 480 pixels display. As I said, this is 4 times more pixels than iPhone. It has touch panels which can be used with fingers or with stylus. You can also use the keys on the sides if you prefer. 2 LEDs on the right side show the status of battery level and charging status. The LED on the left shows the sleep mode, which is implemented to save battery power. Also in front, there is a microphone to record audio files along with the GNSS data. On the bottom right side, there is a headset jack. This was a brief description of Triumph VS hardware. Now let's see what have been done for its software. Let us start with the home screen. On top of this screen, as in all other screens, there are 10 active icons. Each icon gives an overall indication of an item, and then when clicked, opens another screen which shows details. From left to right, there are Ethernet, Wi-Fi, UHF, GSM, GPRS, and Bluetooth. On the right side, there are satellites icon, current map icon, current settings icon, display and speaker icon, and battery status icon. You can click on each icon and see details. For example, the satellites icon, when clicked, shows 20 satellites are being tracked. If you click this icon, you will see the satellite details, which shows satellites' names, azimuth, elevation angle, health status, and their up to 5 signal strengths. Or you can click the battery icon to see the history of battery performance. Also see temperature in different sections of the receiver. This is a great tool to see information in different environmental conditions. On the main sections of the home page, there are many icons. Let's focus on the settings icon. Clicking the settings, you'll access screens to program the operation of the receiver for a variety of applications. Then you can store settings in an unlimited number of files. You can also assign 5 sets of settings to 5 function buttons on top of the receiver for instant reloading of the settings. Let's see some examples. For example, I will program the receiver to track GPS, GLONASS, Galileo, and SBAS satellites. Then I select the receiver to receive RTK corrections via UHF, and I specify the format to be RTCM3. I also limit elevation angles of satellites to 5 degrees. In the duration screen, I can specify the duration to be manual, timed, scheduled, or accuracy dependent. Here, I specify the duration to be until accuracy of better than 3 centimeters is achieved. In the communication screen, I can set up all of my communication channels of UHF, Bluetooth, LAN, GSM, GPRS, and Wi-Fi. For example, for UHF, I select the frequency, output power, and UHF protocols. In the antenna section, I can enter antenna height and specify the type of external antenna if an external GNSS antenna is connected. In photos and voice, I can specify bottom camera's resolution, also the memory location to record images, and also how often to record. I select the bottom camera to record an image once at start and once at the end of the survey. I can do similar with the top camera. I can also program the voice recorder to automatically record my voice for 20 seconds when I start the operation. I can also program that all operations start with 5 seconds of delay after I click the start button to align myself better. I will skip other settings for now. After I program Triumph VS for my particular application, I can store them in a file and later reload them when I need them. I can record unlimited number of settings in such files. I also can assign 5 of my settings to the 5 function buttons on the top of Triumph VS. I save my settings in a file, and I also assign it to function button F1. As another example, I program the receiver to act as a base station and transmit RTCM messages every second via Ethernet. I program Ethernet parameters, antenna, photo, and voice settings, and then store these settings in another file and assign the settings to the F2 function button. Now each time I push the F1 button, my receiver will instantly load my F1 settings. The same with F2 through F5 buttons. You can program a variety of scenarios and then recall them instantly. Now that we have programmed our Triumph VS, let's see how easy it is to use it in the field in a variety of applications. In the field, all you need to do is to turn the receiver on, push the desired function button to make sure that your settings are what you want. Then push the action button in front of the receiver. In action screen, again, active icons are on the top. All you need to know in doing your projects are shown in the action screen. I'll try to explain them briefly. On the top left is the timer box. In manual duration, it shows the elapsed time. In timed operation, which is the case here, it shows the elapsed time and the remaining time. Below the timer box is the satellites box for GPS, GLONASS, Galileo, WAAS, EGNOS, and QZSS. Below each flag, on the left side, is the number of satellites tracked, and on the right side is the number of satellites used. Below the satellites box are 2 boxes for transmit and receive. In this example, nothing is programmed to transmit. The receive box shows it is ready to receive RTCM data. It also shows the quality of the communication line. Next is the memory box, which shows total amount and the remaining memory sizes. On the right side, on the top, is the epic counter. It counts epics when action starts. The box below that is for front camera or to count down delay timer, if any. Next box is the position box, which shows the calculations for the action in progress. In survey operations, it shows running average of coordinates. In stakeout, it shows the offset from the target. At the end of a parcel survey, it shows area and perimeter of the parcel, which is the case here. Next is the position calculation type and estimated accuracy. Here we see RTK fixed is in progress, and the estimated accuracy is 3 centimeters. Next is the recording box. It shows the format and the period of data recording. In this example, the header of the screen shows the parcel name and the parcel point being surveyed. Next is vertical and horizontal level indicators and numbers. Next is the compass indicator and heading. In the footer of the screen is the instantaneous coordinates of the current point. On the right side of the action screen are buttons to control the action. Start and stop are on the top. Clear clears the screen. The next two buttons vary based on the programmed action. In this case, they control the parcel survey and when to end it. View button selects what should be shown in the action screen. Next is review button. You can view the results of the survey. And finally, the antenna icon allows a quick way to enter antenna height. When voice recording is in progress, the audio recording indicator appears here. In the center of the display is the position plotter. If you open the bottom camera, the center of the display is the center of the receiver for alignment with the mark. The screen scale can be changed by zoom buttons. Now let's see how to survey a parcel, for example. We have set up for parcel survey and selected the RTK mode. We have set duration of 10 seconds. With this setup, we go to the first point, align to the mark, and click Start. We do nothing else. The timer will count down, and each calculation is shown on the screen. The final result is stored after 10 seconds. Then we go to the second point and repeat the same. Just align with the mark and click the Start button. We repeat this for all corners of the parcel. After the last point, we click the End Parcel icon. The parcel area and perimeter are automatically shown in the position box. We can also record raw GNSS data in case we want to document survey data or for post-processing it. Other survey jobs are even easier than this. To do stakeout, just select the stakeout mode, select the stake point, and Triumph VS will guide you to the point to stake it. After stakeout is done, you can survey the actual stake with a simple click. Triumph VS will record the intended stake point along with the actual point in the same file and will show the difference. Let me show you one more example. You can survey many points and then convert them to smooth shapes via the Draw menu. Here you can curve fit the points to a single point, a line, a second degree, or a third degree polynomial, a circle, etc. Before closing the software summary, let us look at homepage icons, like a table of contents. Settings was discussed. In maps, you can open, create, and manage maps. Kogo performs a variety of geodetic and geometric calculations. FN buttons show compact view of settings assigned to F1 to F5 buttons. Tutorial has a brief tutorial about Triumph VS. Language changes the language of Triumph VS. Options show the options that have been purchased on this Triumph VS and those which are available to buy. Points is the list view of all points of all maps, and clicking on a point name will take you to the map containing that point. GNSS data is the list of GNSS data similar to points. Images show thumbnails of photos, and clicking on one will take you to the point on the map which that picture was taken. Similarly with audio files. Calendar is the calendar view of data. Clicking on a date that has an activity logo opens the associated map and takes you there. And calculator is a simple calculator optimized for what surveyors need. Contacts is like a phone book that has communication settings, URL addresses, and phone numbers too. Timing shows different times and time interval measurements from 1 pulse per second to event marker, which is used in aerial photogrammetry and in timing applications. Exchange exchanges files, settings, maps, and data between two Triumph VS when they're near each other via Bluetooth, or when connected via USB, UHF, GSM, or LAN. Camera lets you take pictures, and voice recorder to record voice. Support we somewhat discussed. In System tab, there are information like hardware status, resources, and versions. Locks the FN buttons and the settings menu to protect against unintentional changes. In Triumph VS, the description of every item of every screen is described in the caption area on the bottom of the screen. The amount of information on the capture area is about 300 pages of plain text. Adding pictures on the screen, it is something like a 1,000-page user manual. In other words, Triumph VS is self-contains its operation manual. This is a smart operation manual because information is available to you at the right time and at the right place. Now let's get more practical and see how Triumph VS can actually be handled in the field. First, you can mount it on a conventional survey tripod. It is not necessary to put such a small receiver on top of a heavy survey tripod, but we have provided an adapter for this purpose, just in case. You can also use it on a regular pole and use it like a camera. Triumph VS has built-in bottom camera, compass, and inclinometers to align and level it. If you're off the mark, the recorded data and image will correct the offset. You don't have to completely level and align it to the mark. Is this not wonderful? Still easier, you can mount it on a conventional camera monopod and just for secure, put the shoulder strap and hold it like this. It's easy and safe. We also have a special bracket for attaching Triumph VS to poles if you want. You also can use external antenna for applications like monitoring stations where a choke ring is mounted outside and connected to Triumph VS. And last, if few centimeter of accuracy is good enough for you, you don't need any attachment. You can hold it like a conventional camera. The built-in bottom camera and the inclinometers will help you to level and align. And also you can use the shoulder strap for protection. This way you can easily achieve few centimeter of accuracy without any attachment. In office, you can use legs for putting on the table and for better viewing. The magic in doing all these is our revolutionary GNSS tracking and our RTK processing. You can do accurate RTK surveying in a few seconds. How do we do this? The answer is in our 216-channel Triumph chip with additional 110,000 correlators. Now let's talk about our software updates. We will continuously improve our software, and updating our software is fully automatic. Let's look at the support page of our homepage. In support page, you can update firmware, update option files, check your hardware with our server, or send files to us. Even you can ask questions directly via your Triumph VS, and you can view our answer in your Triumph VS. Let's see the update firmware page. You can select your update channel and ask to update now or schedule updates automatically at times that you select. We have many innovative ideas employed in Triumph VS. Some patents have already been granted and some are pending. And finally, about prices. First of all, there is no equipment available today that comes close to Triumph VS. Even if you add up the component prices of the old-fashioned system, you easily get above $20,000 or $30,000. Some charge $5,000 for software alone, which has less features than Triumph VS software. You can easily justify the price of over $30,000 given its performance and additional financial benefits that Triumph VS brings. Today, I will not comment about price. Surprise yourself by visiting our website, javad.com, for Triumph VS prices. You have come a long way, survey. Triumph VS. What is VS for? Is it for versatile survey? Is it for Virginia Slim? Whatever you call it, one thing is for sure, you have come a long way, survey. Our team of over 100 scientists and engineers work hard for a long time to develop Triumph VS. Today, I enormously enjoyed presenting it to you. I hope you enjoyed it too. For further update, please see our website, and thank you so much for your attention. Thank you.